When Commander Frank Borman reached the far side of the moon in 1968, he described it as a place messed up beyond belief. The surface was an entirely colorless landscape of meteorite craters and ancient volcanic residue. But as the Apollo 8 spacecraft completed its fourth orbit, a bright sliver of blue and white suddenly appeared over the jagged lunar horizon. Astronaut Bill Anders grabbed his camera and pressed the shutter, capturing the first high-quality color image of our planet from deep space. This unplanned snapshot presented the Earth as a solitary point of color within a gray wasteland. The image spread rapidly, catalyzing the modern environmental movement and the establishment of Earth Day. In 1968, the view from space contrasted sharply with the ground reality, where major cities like Los Angeles were frequently choked with thick smog during rush hour. At the time, industrial pollution was so concentrated that several American rivers actually caught fire, drawing national attention to the state of the water supply. 58 years later, the Artemis II crew returned to the moon with a specific plan to capture a 2026 equivalent known as Earthset. Placing these two photographs side by side provides a human-scale baseline to measure the physical changes that have occurred in the decades between them. The 2026 Earthset image shows the sunlit Oceania region dipping below the lunar surface, a view defined by blue water and high-altitude white clouds. Unlike the 1960s, our planet is now continuously monitored by thousands of automated satellites tracking every shade of the electromagnetic spectrum, from microwave to ultraviolet. However, an image framed by a human eye carries a different weight. It reflects the conscious choices and emotional perspective of an astronaut looking at their own home. While the framing evokes a sense of awe, comparing the two photos against contemporary data reveals the physical impact of the intervening half-century. This chart shows atmospheric carbon dioxide. Since the 1968 Earthrise, CO2 levels have risen by a full third, leading to rapid warming. Global temperatures have increased by at least 1 degree Celsius in that same window, altering the planet's texture as seen from space. We can see this in the Aral Sea, which has shrunk to less than 10% of the size it was when the first Apollo crews looked out their windows. In the cryosphere, 28,000 kilometers of Antarctic ice shelf have collapsed in the time between these two human photographs. Scientists now attribute between 90 and 95% of these planetary shifts directly to human activity. From deep space, the Earth appears flawless, but zooming in through the clouds reveals a surface marked by expanding cities and the removal of dark forests for agricultural land. While our technology for space exploration has reached new heights since the 1960s, our metrics for planetary stewardship have followed an opposite trajectory. The value of the Artemis mission isn't just in exploring the moon, but in the perspective gained by looking back at our own progress and its physical costs. Frank Borman passed away in 2023, but the legacy of his first voyage into the lunar distance still informs our current missions. Borman noted that while they went all the way to the moon to study its craters, they were ultimately far more interested in looking back at the Earth. His 1968 perspective started a global movement toward preservation that has endured for nearly 60 years. The Artemis Earthset is a document of the time we have left to finish that work, standing as a quiet reminder that while the view from the moon is beautiful, our survival depends on the details below the clouds.